First of all, really thank you for having me. It's a great honor to be here on the stage. So yeah, I would like to talk about our CI/CD process. Yeah, and honestly, I know the title is very catchy. Our journey to efficient and secure CI/CD. So yeah, I don't want to spoil it too much up front. But yeah, before I start with the actual topic, let me introduce you ourselves. So yeah, I'm Marco. I'm at JSMD since 2020, and I'm very interested in tooling and pipeline engineering. I have to be honest, it's not really part of my daily job. I do like more product development, but for me, this is a really important aspect of product development to keep like really fast and snappy deployments. And so that's also why I'm super interested in this topic. And yeah, I have the chance to be the second time at the stage. It's the first time that I'm alone here, so it's quite intimidating, but I try to do my best. Yeah. Talking about us, the Jochen Schweizer mydays group, our mission is to provide the most fitting and memorable experience to the customer. We are also financially backed by the ProSiebenSat.1 Media SE. Actually, they have also a booth close to us. Considering to the company size, I would say we are already in the category of a larger size company. We have like 320 employees. But yeah, in some aspects, we still behave as a startup, which is quite practical. Yeah. And yeah, non-biased fact, the IT department is the coolest of all. So yeah, we sell experiences. Those are our web shops, the mydays shop and the Jochen Schweizer shop. These are our hubs and basically the place where experiences can be provided, can be searched, and can be bought. Yeah, both are technically hosted under one unified platform. Yes. And we do have here our beautiful office close to the Werksviertel. And yeah, this ugly image is not even closely doing its justice on how nice the office is. So not only on the location-wise, but we really have like a nice terrace with beautiful views to the Alps at times, nice sundowners. And we even have a slide from the 4th floor to the ground floor. Yeah, we cannot really complain. But okay, let me start with the actual topic of this talk. And this is trunk-based development. It is really a foundation of our CI/CD process. Yeah, probably it makes also sense to explain just briefly what trunk-based development is. So usually you have a core branch and you have feature branches or bug fix branches. And the aim is basically to provide a lot of changes from your feature or bug fix branch to the main trunk. And after merging the changes to the main trunk, if the pipeline flags up any kind of failures, it is really, really important that everyone jumps in and tries to keep the main trunk really again in a healthy state. So the target is really to have a healthy main trunk branch and to release often, to really release frequently. Yes, so small feature branches, core trunk branch, what I already mentioned. We also do have merging and integration in one phase. How this looks in detail, I will comment a bit. And yeah, we also make use of feature flagging. The advantage of using feature flagging is that you do not necessarily need to develop the complete feature in order to merge a change to the main trunk. So the feature can be 50% done, but when you hide the specific functionality behind a feature flag, you still can merge it to the main trunk and simply don't leak this halfway feature to the customer. Yeah, it's really a nice complementary part of the trunk-based development. Yes, and this is how our integration, merging/integration phase is looking like. So whenever there are changes applying to the main trunk, to the main branch, the changes will automatically be applied to the development stage. This is our first quality stage. Usually, this is also the stage where the engineers are more doing their tests, so they expect that the specific feature is behaving the same as while developing locally. So after the testing from the engineer has been done, we deploy to the next stage, and this is the staging stage. This is our second and also last quality stage. Hopefully, by then, we have the bugs caught already. Otherwise, we would have a problem. So, what we're trying to do is that on the staging environment, we are trying to keep it as close as possible to the production environment. Like, be it cluster configuration-wise, because we work with Kubernetes, or data-wise, we really try to have like a mirror of the production environment. This is also usually the stage when we develop features, and they need to be approved by stakeholders because, of course, they request for new features. This is the stage where it's been done. And after this is then done, we can deploy to the production environment where basically it's user-facing. Testing. So the primacy of keeping the main trunk really in a deployable state is that we need to encourage people, engineers, please write tests. It's really important. So what also helps us along this way is to monitor the test coverage, and we also have metrics for this, of course. We also have different kinds of testing levels, from unit tests until end-to-end tests, and usually the higher up the pyramid you will go, the more effort it is to maintain those tests, because they also rely on external factors. Like end-to-end tests relies on a database, and so they're not so cheap to develop and also to maintain. Yes. So, how do we utilize tests in our CI/CD? So, for these short-running tests, like unit tests, component tests, and integration tests, we run them locally on feature branches and whenever we merge the changes to the main trunk. So these tests are being run with the pipeline when applying the changes. End-to-end tests, however, they take super long. So we try to keep them in separate pipelines that also run asynchronous in specific intervals. This helped us to keep also our pipeline relatively fast. So the end-to-end tests are running, let's say, on every 10 minutes, and they run against full dev and staging environments. So whenever someone, an engineer, deploys something to dev environment, he can already see that if a change broke something, he will probably see it in the end-to-end test in the report. I think what is also important to mention is we do not have a quality assurance department. So these tests are our life insurance. So after every change, we really need to be confident that a new feature is not breaking existing behavior. So we put a lot of effort on the health status of these end-to-end tests. Generally, not only end-to-end tests, but all kinds of tests. And we try to keep the test coverage relatively high. That's very critical for us. Yes, not only testing we make use in our CI/CD, but also SAS tooling. So I need to look up. So SAS actually is automatic static code analyzers. So we do make use of SonarQube, and SonarQube helps us to automate specific parts of the review process when doing code reviews, like really simple stuff that maybe we could also catch, but we want to automate things as much as possible, right? Why not automating things if you can, right? So, I mean, one important thing that I have to mention is that these SAS toolings cannot really provide feedback about like code design patterns. Like, it cannot. And maybe also, if they can, maybe not good enough. Just being honest. So we really try to intensively review our code, but it helps us maybe some things like code smells or semantic code checks. For that it really helps. This is an example of a quality gate result from SonarQube. This is being printed basically on every change, on every merge request. And yeah, you can also see like the coverage on new code changes. When you click on the report, you will navigate to SonarQube and can see also the trend over time with the code coverage. And yeah, there's some quite interesting data that you can look upon. Yeah, logging and monitoring. Logging and monitoring is really critical for our delivery, continuous delivery, because they provide real-time data about the behavior of an application before, during, and also after deployment. And coming to what a log actually is, it is a time-stamped record of an event produced by the application. So it can contain data about maybe user inputs or the state of a specific process in the application. In order to ensure that our deployed features are behaving against anomalies, we need to include logging. So we make our system a bit more observable. Yeah. So yeah, we do incorporate 4 kinds of logging severities. And this helps us engineers in order to know what the urgency of these damn logs are, because we have quite a lot of them. Also, in the beginning, when building, so we work with microservices. So when creating a complete new microservice or a complete new feature, it is also natural in the beginning to log more. To see how the application and the system is behaving against errors. And like over time, by gaining more experience, yeah, it is also okay to reduce the amount of logs that you have and also to adjust the severity of these logs as needed. For example, going from error to warning, or yeah, this is just an example. What is important to mention is that for debug logs, these are usually not enabled, and we start from there until error logs, and error logs are quite business critical. So if we have error logs, it will notify appropriate people also in the night. So, yeah. We also have different observability platforms depending on which kind of log. So considering the request flow from the user until our backend, so for ingress controller logs from the Kubernetes cluster or maybe Lambda function logs, we use Amazon CloudWatch. Front-end exceptions are captured by Sentry. So not really front-end, but browser exceptions initiated by the front-end are captured by Sentry. And the further down the request will go to our microservices, you will see our logs end up in Datadog. Yeah. So I talked briefly about feature flagging, but we also have A/B testing coexisting for our continuous delivery flow. Yeah, illustrating the difference between both of them because you cannot necessarily compare them. So feature flagging is like a gatekeeper, on, off for a specific feature for a deployment. Very simple, very simple. Optimizely is our tooling for A/B testing, and it helps us rather to prove or disprove hypotheses made by someone. It is very user-driven feedback approach and shows data about product performance. If I could sum it up, I would say feature flagging helps us to decide when we enable a feature for the user, and A/B testing helps us to decide what kind of feature is good for the user. This is how I would, distinguish it. Yeah, this is my favorite part of the of this talk: pipeline efficiency. So, also not for us, not everything is perfect from the get-go. This is an example of an unoptimized pipeline, and this is like a merge request pipeline, and just a simple change could yield to 21 minutes pipeline duration, which is quite damn long, I have to say. So this is also a bit contradictory with our approach of having frequent releases. How frequent can you be when you have so long pipeline executions? So, and obviously the outliers are the build job, which took almost 8 minutes, and the test, which took 12 minutes. So overall 20 minutes from 21. Yeah, that's pretty bad. I try to be fast. Yeah, so one approach that we try to do is utilizing Docker caching. Now it's getting really nerdy. So let's assume for the following use case, you do source code changes and dependency changes. On the first time, maybe you don't have a Docker artifact where you can compare the cache of. So you Docker builds everything from scratch. On the second build, however, with Docker caching, we are able to pull the Docker artifact from the former build and can compare each layer against each other. And if everything goes fine, we can even reuse the whole cache. And in specific scenarios, we were able to reduce the build time from 465 seconds to 29 seconds, which is quite good. Of course, this is not always the case. Let's be real. But already caching a few layers already helped us reduce the build job duration. Yeah, about the test job that took 12 minutes, what we did previously, we would do the type checking, the lint checking, and the testing all in one sequential process in one job. However, SonarQube only relied on the artifacts of the test job, of the coverage artifacts. So what we try to do is we try to split the test execution from the type checking and the lint checking, since they anyway do not really necessarily rely on each other and they run concurrently. And the time that we saved there overall is the time that the type checking and lint checking took for execution. Yes. I'm almost done. So this is also right now a bit experimental. We are using Webpack as module bundling. I mean, it's very established package, probably over a decade. But there are also some new tooling bundlers in the market, like Vite or RSPack, which is a rewrite of Webpack in Rust, more or less. And I tested it locally on my machine, and the result was already quite good, from 86 seconds to 23 seconds. Of course, in a pipeline with limited resources, the improvement can even be better. Wrapping up my talk. So the takeaway is that eventually things get really worse if you do not really continuously refine your CI/CD. This is really something that we also had experienced. We somehow neglected also our CI/CD and the efficiency of it. But yeah, after taking some brain power in it, yeah, it helped us to improve the duration of our pipelines. Yeah, I hope you had some good insights about how we deliver features to the customer. And yeah, that's it from my side.
Thank you so much for this interesting topic. Big applause. So we have time for one question, actually. So who's interested in one question? There is one.
How much coverage are we really talking about, and how much code coverage in percentage?
So by default, we try to start with 80. But I think also on, let's say, business critical microservices, maybe also in the order processing domain, I would argue that it should maybe even be higher, that we also need to test every kind of edge case. I'm not personally on the order domain, I'm in the more product discovery, but yeah, that's just my 2 cents. Yeah.
Thanks again to Marco Leko for this interesting talk.